So, one of the things that probably aware of, but in case not, we'll kind of discuss through it just a little bit. You are studying right now to become an engineer, and that means that you are probably interested in stuff, like how do things work, and you're going to try to learn how things work, right? Mostly you're studying that kind of thing. But one of the things that you will also likely deal with in your career and otherwise, you will likely deal with how finances and sort of financial resources play into the decisions that you are going to make and the things you'll be responsible for as an engineer. So give me some thoughts as to how do you think this might come about? Yes, ma'am.
If you are assigned a project with a budget, and so you have to find the cheapest materials available, or you have to conserve money.
Okay, so basically her answer is that you will have to basically make design decisions, okay, where you are maybe picking out certain kinds of equipment. You might be picking out a certain way of doing something, right, an overall process, and finances is going to be one of the things that you have to look at. So you might have to make a decision between one way of doing things and another because of a financial consideration. Okay, so that's good. What else? Yeah. Okay. So save money, okay, for your company. Okay, and that kind of goes with the last one, right? But it's this idea of if you can save, especially if you're doing a lot of something, if you can save a half a penny on every one that you do, that might end up having a huge bottom line savings for the company that you work for. Yeah.
I mean, you want to make money. So, you're building stuff, designing stuff for a profit to sell to people.
Right. So again, his point is you want to make money for your company, or if you might be working for yourself, and in that case, you want to make money for yourself. So these are both things that you're going to have to do, and sometimes you have to choose among choices, and one of the considerations you have to do is based on finances. Okay. So I agree with all of those. Anywhere else where you feel like you might need to have a little bit of financial prowess to deal with things? Loans, okay? And so maybe I'll say your personal life. How many of you think you might buy a house at some point? Okay, I see a lot of hands going up. How many feel like you might want to buy a car at some point? Okay, so these are decisions that you're going to probably make along the way, and as you do this, often you are not going to already have all of the capital that you need just to make that big purchase, right? So you are basically going to decide to try to use someone else's money to make a big purchase that you need right now. Okay, so these are what we're going to learn in this segment of the course is some things that go into what we call the time value of money. Has anyone ever heard that phrase before? Okay. And basically the idea is that $1 today is not necessarily worth the same as $1 that you might get a week from now, or the $1 that you might get 2 years from now, right? If there's a potential to get $1 2 years from now, even if it's a guaranteed thing, that $1 that you're going to get 2 years from now is not worth as much as the $1 that you have today. Okay, does that make sense? So that's kind of the main thing that we're going to look at with respect to this topic that we're going to call as a big heading. We're going to call this engineering economics. Another area of campus might refer to this as sort of finance, right? We're going to learn some of the basics of finance. Any place else where you feel like this might end up being a big deal? Well, how about this? You might not be aware of it, but a lot of big companies, the person who winds up being the CEO of the big company, the person who's kind of ends up being the big cheese, many of them started out being engineers, right? And for whatever reason, they may have gone through the ranks of doing, more dealing with the stuff, but at some point they made a transition and they started dealing probably more with people and, big project considerations like budgets and like finances. And so they might go up that track to the point where they have a role as a big leader at the company, in which case this is a lot of what they're going to deal with is the issue of finances. So anyway, so this is kind of our big heading we're going to go into today. We're going to look at the two specific cases of simple and compound interest. Okay? So the first one is the idea of simple interest. Okay? And this is so simple that it's almost, I almost can't believe we're talking about it, but it is a good place to start. So, with simple interest, what you do is you have to pay in order to have money now that is not yours, right? This is, again, comes back to the time value of money. If you are a bank or some other provider of capital for a purchase or something that you need to, that the borrower needs to make right now, you're willing to do that because the borrower is willing to pay you for that service, right? So that is what makes money that you have now worth more than money that you might have later, okay? So that's kind of the idea here. And if you're dealing with simple interest, it basically works like this. First of all, we'll define some terms. So P is something that we will generally, we'll call it principal. Okay? And it is basically the amount of money that is kind of the origination of the loan, so to speak. We can kind of refer to these things as loans, but we're going to get this to where it's more generalized than just talking about loans. So this is sort of the initial transfer of money. We'll talk about principal, okay? Then we have another variable that is I, lowercase I. What do you think this is? Okay? I is interest, but I'm actually going to say interest rate. Okay? And so this is actually an interest rate, and I'll say interest rate per specified period. Okay? And another variable we're going to use with this is n, okay, lowercase n. And n, what do you think that is? Okay? Number of periods. And I'm leaving this as general as I can. Often, your period is going to be a year, right? That's the period of time over which you are dealing with this, but it doesn't have to be. So that's, where I'm going to leave that kind of generalized like this. There's another variable we sometimes use, and it is capital I. What do you think capital I is? Accrued interest. Okay, and so the formula that we use for simple interest is basically, because with simple interest, the borrower is only going to pay interest on the original amount borrowed. And so what you will find here is that the amount of interest that they have to pay, I, is going to be what? Whatever your principal was times what? Times the number of periods over which you have that money out times what? Times the interest rate. So PNI. Okay? And so how much would you actually have to pay back? So a lot of times that is going to, where the letter we're going to use for that is sort of F, which is a future value. Okay? And if you know that your future value is going to have to be a certain amount, that is basically how much would you have to pay back at the end of this loan. How would we set that up for this problem? Or for this particular scenario of the borrower only paying interest on the original amount borrowed? It would basically be the original amount plus the accrued interest, which is what? P plus PNI, which is what? P times 1 plus NI. All right. So up here we sort of have all of our variables defined. There we have our accrued interest, and now we have the future value being equal to the present value plus the accrued interest which turns out to be just the present value times 1 plus ni. So how would I work this little problem right here? So you have some health problems. You have a coworker, Sue, that offers you a simple interest loan of $2,000 to help you out with these expenses. Okay? She says you can pay it off after 5 years. All she wants is 2% of annual interest, maybe just to sort of help with the idea of inflation. Okay? So after this period, how much will you have to repay to Sue? Okay? What would we do? Okay? F is the future value, which is what you're going to have to repay to Sue. It's going to be equal to P times 1 plus Ni. So what's P? $2,000 times what? 1 plus, okay. Yeah, we have 5 years. That's N, right? So we put in here 5 times what? Okay, 2% annual interest, we can write that as 0.02. Okay, and we can then calculate how much we have to pay back. Okay, so we put in here 2,000 times 1 plus 5 times 0.02. So she wants $2,200 back. That doesn't seem like that hard of a problem, huh? Questions yet? All right. So now we're going to move on. This is actually a fairly uncommon way to get loans, as some of you might be aware. What is more common than this, would you say? Okay. Compounded interest is the name of the other way that this is typically done. So with compounded interest, what we have is that the borrower not only pays interest on the original amount borrowed, the borrower also pays interest on the amount of interest that has accrued over the life of the loan. Okay, so you kind of keep a running tally of what do I owe right now, and that's what you pay interest on. Okay, so what we need to do is look at this problem. I'm going to go to a bank and get a small business loan of $6,000. Okay, we're going to say that the interest rate is 7% annually, and I'm going to repay this 3 years from now. And what I want to do is figure out how much do I have to pay back if the loan is compounded, and we're going to do this for a few different cases. One is annually, one is monthly, and one is daily. Okay, and so what we're going to do is we're going to solve this problem in a spreadsheet because it involves a lot of sort of repeated calculations, which is where spreadsheets shine. And we are also going to make the assumption here that this 3 years happens in between leap years, so we won't take into account the weirdness that happens where every 4 years we get an extra day. Okay? All right, so what should I do? Okay, we'll open some Excel here. We got compound interest here. And I've started with a little example sheet. Okay, so help me remember, what were the parameters of my problem? Okay, $6,000 loan. What that means is at the beginning of the first period. Okay, for period 1, the beginning of the first period, what's my balance going to be? $6,000. Okay, and I've already set these up to where they will format as currency. In case you're curious how to do that, you can select cells and go up. This might look a little bit different in newer versions of this software, but you can go up here and select currency as the format. Not that you absolutely have to do that, but it makes it look like money. Okay? All right, so in that first period, how do I calculate the interest that was accrued in that period? What do I need? my interest rate. Okay, I want to show you something cool here, or at least I think it's pretty cool. What is 7%? 0.07, right? So I'm going to put that in there like that, and if I, just hit tab or something, go to another cell, it will stay that way. But I want to show you another format that you can do for your sheet. If I select that cell, one of the formats I can use up here is a percentage. Okay. Now the thing is, the contents of that cell have not actually changed in terms of the numerical value, right? It just changed how it displays for you. Okay. So that's actually really handy. So it keeps you from having to do things like divide or multiply by 100, right, in a manual sense. Okay. So there's my interest rate. How do I figure out the interest accrued in this period? Okay, it's 7% per year. That's what annual means, right? It's 7% per year. So this should be whatever my balance was times what? Just times that percentage. Okay, that's how much interest I have to pay for just having the money out this period. Okay, so it's one period. So if you think of P, N, I, right? N is 1, so it's basically just PI, because I'm just dealing with just one period here. All right, so how do I get this multiplied by that cell properly? Yeah, right. So we need to actually do an absolute reference to this cell instead of a relative reference. Okay, so I need to put some dollar signs on there, and the quick way to do that is with the F4 key on your keyboard. If you type F4, what you'll see it do is cycle through a few different options for which item you would like to lock in. Okay, and for us, I'll say it doesn't really matter that we lock in one or the other. We can just completely lock it in, and that's fine. So $C, $2, and that's it. So that means in the very first period, we would have accrued about $420 of interest in that first period. So what would our balance be then at the end of that first period? Yeah, so I just take the interest the balance I started with and add to it the interest. Okay. And that gives me my balance at the end of that period. All right. Next question is, how many periods? Okay, if you go back to the original problem said we're going to expect this to be like a 3-year long loan. So how many periods do I need? 3. And we're going to be able to find what the balance is at the end of the third period using this technique. Okay, what should I have at the beginning of my second period? Yeah, it's whatever I left off with at the end of my last period. So I just put an equals and reference whatever I had at the end of the last period. Then what? Ah, good idea. So we're at the point now where the formula that I had in this cell, there's no reason I can't just drag that down. Right? All it's going to do is apply to the cell that's to the left, and it's going to use an absolute reference that continues to reference C2. Right? So I should be able to just drag that down, and that does work. What about the next one? I should be able to drag it down. And once I get it to this point, I can take all 3 of them and drag them down. And what is my balance there at the end of the third period? $7,350.26. Okay, this is for compounded interest where we have an annual interest rate of 7% and it is compounded annually. Okay, what's next? Okay, because it's asked us to do this a few different ways. Annually, next one says monthly. All right, so going back to here, okay, maybe I'll put a big heading up here. This is compounded annually. Annual Okay. All right. What about our next way of doing this, you think? Compounded monthly. So first thing I need to do for this is figure out what is my monthly interest rate. How do I figure out a monthly interest rate if I want to continue using an annual interest rate of 7% to figure out the equivalent monthly interest rate? Yeah, all you do is you just take whatever you started with as that 7% and divide it by however many months there are in a year. Okay? And I'm going to take that and also display that as a percentage. Okay? And so here I'll call this a monthly interest rate. And then I will format that so that it looks nice. Okay? I want to use the same headings here. And then what do I need to do? How many periods? Let me ask that question. Okay, I'll have 36 periods. How do I know that? Okay, so if I start that sequence and just type a few in, I should be able to drag this down however far I need to indicate I've got my 3 years. So 36 periods is what I'm dealing with. Then what? Same thing, right? I put in 6,000 for my initial balance. Now I figure out what the interest was that's accrued in that first month, because that's what the period is now. And so what do? Just take the 6,000 and multiply by the monthly interest rate. Again, I want to lock that in. And I can then figure out what the period or what the balance is at the end of this period, which is just going to be the sum of these two values. Okay. Once I have that, what do I do for my beginning of the second period? Just whatever I left off with at the end of the last period. Okay. What do I do with this one? Drag it down. This one, drag it down. And now I'm ready to take all three of these and drag them all the way to the bottom or to the 36th month. And what we have here is basically a table that says for each month of my 36 months, the amount that you have here is basically at the beginning and end of each of those periods, how much will I owe, kind of in a live way, right? Each month it gives me my updated value. And so rather than owing $7,350.26, now I'm going to owe $7,397.55. More or less? More. Would you expect that? Yeah, that seems right, that it would actually cost you more if you are having to pay interest on your interest more often. Okay? What if you go every day? Okay? Well, let's look at it. So we'll go to compounded daily. Okay, so this is a daily interest rate. And that would be what? Okay, 7% divided by 365. Okay, and that's what it would be as a decimal. I can also make that show up as a percentage if I would like. I might not like that it shows up as just 0.02. Is that accurate? It's got it inside of there. I agree with that. But sometimes this kind of can throw people off. I would actually like to show a little bit more precision on that. You can do that with these little buttons up here to show more or fewer decimals, right? So if you go like this, that's actually the wrong direction. You go this way, and it'll actually show you more of those decimal places, and you get a little bit better idea of what that number really is. Okay. Okay, down here, how many periods? Okay. 365 times 3. Okay? Tell you what, I'll just do this right here. I'll say number of periods. All right, and I'll do a quick calculation to figure out what that is. Here we have 365 times 3. So 1,095 periods is what I'm going to have to actually deal with here. So I deal with it. And we do some scrolling. 1,095, right? And unfortunately, it gives you this little thing off to the side, and it makes it a little bit easier to see, you know, where you can stop. Is that annoying? I think so, right? Having to do 1,095 of these, you know, I'd rather not have to do that. We'll come back to that in just a second. Okay, so I'm scrolling up now. Now what? 6,000? Okay, this is no different. We're just going to take 6,000. The interest accrued in the first day is going to be what? 6,000 times that daily interest rate, okay, which I will lock in to that cell. So in that first day, it costs you $1.15 for the privilege of having that $6,000. All right? So then at the end of that first period, you will then have a balance of the sum of these two. Okay? The beginning of the next period, you just have whatever you left off with at the last period. And now what's the interest accrued the second period? Okay? Not very much more, but a little bit more, right? We don't see that part of it, but it is a little bit more. Then what? Okay? I can drag this one down as well because all I need is the sum of the beginning balance plus the interest accrued that period, and now I have what I have in the second period. So now what? Oh yeah. We grab those and we're going to copy them down and have a little conversation amongst ourselves while we wait. Isn't it great? Okay. We're waiting, we're waiting. I mean, you know, sometimes it's good to get to know each other, have a little bit of time to catch up. All right, we get to the end. Now how much, we figure out how much this cost us, okay? Well, how much different is it though, really? 7,401.92. Okay, 7,401.92. Let me write these down. Okay, 7,401.92. Okay, what was it for monthly? Okay. For monthly, I had 7,397.55. And what was for the yearly? $7,350.26. Okay. Are we really talking about a ton of difference? Okay. So that's actually a very interesting thing. Okay. Someone says between monthly and daily, there's actually not that big a difference. Right? The big difference happened where? Yeah, from going from annually to going to monthly. Okay? There's a big difference that happens right there. Just basically one way of interpreting this is doing any compounding sort of at all is where you get your biggest difference. And how often you compound sort of has a diminishing effect as you compound more and more and more and more frequently. Okay? Yeah, it's on $6,000, but, you know, having said that, even that on $6,000, you know, $4 is not an incredible amount. right? Okay, fair point. His point is, this is only a $6,000 loan. If you had a $200,000 loan for a house or something like that, then this would be a bigger amount of money. But on a purchase like that, it's also, you know, a lot of times you evaluate cost based on as a percentage of what the purchase was, right? So maybe something that would be in the several hundreds of dollars of range, for instance, may not be that much when you're looking at a house, right? So now we've done that. Question I have for you now is this. What if you didn't want to use a big old spreadsheet? Okay. Is there a way that we could generalize this process so that instead of having to use the big old spreadsheet where we drag down 1,000 cells, is there a way we could get to the answer immediately with just one calculation? Okay. And many of you may have even seen this before, but what we're going to do is we're going to develop this method of coming up with directly how much the total amount, the future value is, for instance, is going to be in just one calculation. Okay? So here's how we'll do it. We'll do it for two different cases. We'll first look at what if we just have two periods. Okay? We'll do it all in terms of variables. So, for this problem, what would the variable be that I would use for my beginning balance of the very first period? P. Okay? In that very first period, what would my calculation be for how much interest would have accrued in that period? Okay? PI. Okay? So what's my balance at the end? P plus PI, or the other way I could put that is P times 1 plus I. Now what's my balance at the beginning of the second period? P times 1 plus I. Okay. And what is my interest accrued on that? Okay. I would say it is whatever my current balance was, which was P times 1 plus I, times what? Times I. Okay. And so then what is my balance at the end of that period? Okay. So then I would have, P times 1 plus I plus P times 1 plus I times I. Okay, well now what? Well, I probably ought to expand that some, okay, and kind of get everything collected. So this is basically P plus PI plus what? Here, where I've got P times 1 and this multiplied by I, that is going to be P times I, right? And then what? Then I have P times I, so P here times I times I. So what's that last one? Okay. Okay. And this is, what I would say after two periods, this is my future value, right? And I can do one more step and I can say the future value will then be equal to, I can factor the P out completely, and then I have that P times what? 1 plus 2I plus I squared. All right. Fair enough for two periods. I promise we won't keep on going after 3, but let's do 3. Okay? We'll do the case of 3 here real quick. So what do I do there? Okay? The first steps are no different, right? I can take all of what I just did over here and copy them over, right? But what's next in the next line? Okay, well, since I simplified this down here, maybe I'll use my simplification, right? All this stuff right here, you know, this all simplified down to this right here. So maybe I'll put that in here and say at the beginning of the third period, I have P times 1 plus 2I plus I squared. What's my interest in that period? Okay, all of this times I. So I have basically P times 1 plus 2I plus I squared times I. So then what's my balance at the end? You add these two together, right? So the balance at the end just becomes P times 1 plus 2I plus I squared plus P times 1 plus 2I plus I squared times I. Now I need to expand all of that and get everything collected. Okay, so we'll do that and in as short an order as possible. So what I see happening there is that we would have F would be equal to, we'll start with the very first one, right? We'll start with P times 1 plus what? 2pi. Okay, then what? Plus pi squared. Then what? Plus pi. Make that look a little bit better. Pi. Okay, then someone says we need 2pi squared okay, plus pi cubed. All right, now let's collect the terms that are like, right? So the first thing we'll do is we will deal with the p's. All right, every term has a p in it, so factor that out. Then what? I'll have 1 plus, okay, here I've got 2pi, but I also have a pi right here. So I have 3pi. Okay, yeah, just 3i, correct. Then what? Okay, the next thing I'll do is see that I have pi squared here and 2pi squared here. So that turns out to be 3i squared. Okay, and then lastly, I have I cubed. Okay, and so there, I would say that what I have here is represented here. Now, do you start seeing a pattern here? Okay. Some of you may have seen this before, others of you may have not. Have you ever seen a pattern that looks something like this? It looks like a cake. Someone's hungry, I think. What am I doing with this pattern? Okay. Has anyone ever seen this pattern before? You know what this is called? Okay. It is a triangle. It is kind of a shape like a triangle. This is called Pascal's triangle. Okay? And what's interesting about Pascal's triangle is it has an interesting thing that it's related to, and it's called this, the theory that we're about to look at is called the Binomial Theorem. Okay? The Binomial Theorem basically says that these numbers that you have in Pascal's triangle will be the coefficients of an expansion of a binomial to a power, right? So, for instance, x plus y to the third power. What does this end up being? Okay. If you expand this out, this ends up being x cubed plus 3xy squared. Okay. All right. This is one example of a binomial expansion that you can do with the binomial theorem. All right. Do you see something that this is related to? Yeah, so with our problem that we are working on right here, it is the expansion of a binomial. What binomial is it the expansion of? Okay. What we'll say here is that for compounded interest, f is going to be equal to p times what, you think? 1 plus I raised to the nth power. Okay, so we did this for these two scenarios right here, for 2 and for 3. What I'm pointing out here is that this pattern holds. Right? We could have done the same thing for 4, and we would have come up with the same conclusion. Okay? So this is actually really handy. How so? Yeah, we don't have to write it all out. We can go back to our original problem up here, and we can do, like, for instance, the question of the annual interest, $7,350.26, that we calculated earlier, and I can get that directly. I can do that by doing this, right? F is going to be equal to $6,000 times 1 plus 0.07, right, raised to the number of periods, which for this problem was 3, right? Okay, so here where I go 6,000, I do that times 1 plus 0.07 raised to the third power. 7350, 26. Is that the same thing we got? Yep, sure is. The next question is probably on everybody's mind. How do you subdivide periods if you're using this formula? So let's say you wanted monthly interest rates. Okay. Well, let's do that in example form. We'll basically say for our problem, we had $6,000. This is if we're going to go to monthly. What do we do here, you think? 1 plus 0.07 divided by 12, right? We're going to take that and turn it into a monthly interest rate instead of an annual interest rate. And what do I need to do to my number of periods? Okay, I take my original value of 3 and multiply it by 12. Okay, so here I do 6,000 times 1 plus, okay, I'll put in here 0.07 over 12, and I'll raise this whole thing to 3 times, oops, raise it to 3 times 12. This gives me 7,397.55. Okay, and that answers my monthly question. Okay, what about daily? Okay, just like you might expect. We basically take our annual interest rate of 0.7, divide by how we are subdividing that annual period, and then we're going to raise it to 3 times 365. Okay, 6,000 times 1 plus 0.07 over 365, right? And this is going to be raised to 3 times 365. $74.01.92. Okay, so this is kind of daily compounding. Okay? Any thoughts? You didn't know where it came from, right? Yeah, his comment was, well, we learned this equation in his algebra class, but no one told him where it actually came from, and that it actually isn't that bad to kind of figure out, at least if you're somewhat familiar with the binomial theorem, right? That is a step that's sort of not necessarily trivial to go from one of those to the other. But anyway, any thoughts or questions? All right. Well, that is our first exposure to engineering economics. We are going to get deeper into this and look at it from a few other angles as well. But now you know how to deal with compounded interest either by doing a spreadsheet or by directly using some formulas like this. So I hope it's been helpful for you.